z minus a1 plus I b1 equals to z minus a2 plus I b2, and here there might be some number which would be more than 1. Now in this case we will not be sure whether this is a perpendicular bisector, although it could be, but it could also be a circle. Most of the time it is a circle. So in order to be sure about this, we have to actually break this down into algebra, meaning putting z equals to x plus iy and figuring it out. Let's do an example. So we have a question: absolute modulus of z plus 2 minus 7i equals to 2 z minus 10 plus 2i. So since there is a number outside the absolute value modulus, and for that reason we cannot be sure that this is a perpendicular bisector or a circle. So for that we have to break this down in the Cartesian format. So first of all, instead of z we write x plus iy, so plus 2 minus 7i, and we have 2. So instead of z we write x plus iy minus 10 plus 2i. So what we do is bring the real portion together, so x plus 2, and if we take the I common, it would be y minus 7i, and this would be x minus 10 plus y plus 2i. Now the modulus is going to be square root of real portion whole squared plus imaginary portion whole squared, and this is going to be square root of real portion whole squared, imaginary portion whole squared. Now if we send this square root to the other side, the whole thing becomes whole squared. It would be x plus 2 whole squared plus y minus 7 whole squared. Then 2 square is going to be 4, and square of square root is going to be to the power 1. So x minus 10 whole squared plus y plus 2 whole squared, and we have this format. Now we can break this down. This is going to be x squared plus 4x plus 4, y squared minus 14y plus 49, and this is going to be 4 multiplied by x squared minus a minus b whole squared is 20x plus 100 plus 4 y squared plus 4y plus 4. And if you break this down, this is going to be x squared plus 4x plus y squared minus 14y, and we have 49 plus 4, which is 53, and this is 4x squared minus 80x plus 400 plus 4y squared plus 16y plus 16. So if we bring all the x squared and y squared together and simplify, so this turns out to be x squared minus 4x squared plus y squared minus 4y squared, then plus 4x plus 80x, then minus 14y minus 16y, then plus 53. Now 400 plus 16 is 416, so minus 416 equals to 0. Then we have minus 3x squared minus 3y squared. This is going to be 84x. This is going to be minus 30y, and this is going to be 53 minus 416. 53 minus 416, which is minus 363, equals to 0. Now if we divide both sides by minus 3, turns out to be x squared plus y squared minus 84 divided by 3 is 28 plus 10y plus 121 equals to 0. Another review. If you have a circle in the format of x squared plus y squared plus fx plus gy plus h equals to 0, then the center of the circle is going to be f divided by minus 2, g divided by minus 2. and the radius is going to be square root of the x-coordinate of the center, which is f by minus 2 whole squared, then the y-coordinate of the center whole squared, which is g by minus 2 whole squared, minus the constant, which is h. So this is the radius of the circle. So from here we can write the center of the circle as the coefficient of x divided by minus 2, the coefficient of y divided by minus 2. So it is going to be 14 and minus 5. And the radius is going to be square root of x squared plus y squared minus the constant, which is 121. So this is going to be 14 square is 196 plus 25 minus 121. So 196 minus 196 plus 25 minus 121, and that is 100. So this is square root of 100, which is 10. So we know the radius and we know the center. So obviously this is not a perpendicular bisector line, but a circle with center 14 minus 5 and radius 10. So the idea is, when you have a transformation which has a lambda, which means a number outside the modulus, you cannot be sure whether it is a perpendicular bisector or a circle. You actually have to check using algebra and figure out what it is. But most of the time it turns out to be a circle.